All right, over the next couple weeks, we're just going to pick up a few things we didn't get to, unfortunately, before testing that I think will be important going forward. And the first one is finding the area of a regular polygon. This will be a pretty short lesson, but just a little bit of vocabulary to start us off. A polygon, it says a plane figure, so that means a flat shape with 3 or more sides and angles. So polygons would include all your triangles, quadrilaterals, pentagons, hexagons, octagons, and so forth. When we say something's regular, and this word's come up many times before, that just means that all the sides and all the angles have exactly the same measurement. So in this picture, if this is a regular hexagon right here, what that would mean is that all 6 of the sides are the same length, and all 6 of the angles are exactly the same measure. So that's regular polygon. Then this is a new word, apothem. Apothem is kind of like, it's almost like the radius of a polygon, but it's not really a radius because radius is something that's specific to circles. But it's kind of the same idea. You start with the center of your regular polygon. And one thing that's important to know is if your polygon, if your shape is not regular, then it doesn't really have an identifiable center. But if it's regular, if all the sides and angles are the same, it has a center point. And if you draw a line segment from the center to any of the sides so that it's perpendicular, so it meets at a right angle, that is called the apothem. And one thing that always happens is the apothem always hits the side and bisects it so that these 2 parts are always congruent to each other. But that's what the apothem is. It's this little line segment from the center drawn to any of the sides so that it hits at a right angle. And we have this formula that we can use for any regular polygon, regardless of how many sides it has. And it's number of sides times the length of one side times the apothem divided by 2. And I'm going to show you really quick why this works the way it does. So we have this, this is a regular hexagon, and let's say for the purpose of this that every side of the regular hexagon is 10. So all the sides are 10. And let's say the apothem, this line segment here in the middle, is 7. Well, if you look at what we have here, if you go from the center point and go to these vertices, and that's a terrible line, you get the point, you make these triangles. And that triangle I just drew has a height of 7 and a base of 10. And we know that the area of a triangle is base times height divided by 2. So if we wanted to find the area of this triangle I just drew, we would take 10 times 7 and divide it by 2. And then if you look some more at this, what you'll find is that this hexagon is actually just 6 identical triangles. So once you find the area of this first triangle, to find the area of the whole hexagon, all you would do is you would multiply that by 6. So that gives us this formula that we have up here, where you take that area of the triangle, which is the length of the side times the apothem, base times height, over 2, but you also multiply it by the number of sides. So since this is a hexagon, the area would be 6 times 10 times 7 divided by 2. So it's 6 triangles. All 6 triangles have an area of 10 times 7 divided by 2. Now, you could plug this in a calculator if you want to. One thing I like to do, if I have an even number on top, like I have a 6 on top, I have a 10 on top, I like to simplify my fraction a little bit. So what I can do is I see a 6 and a 2. I can simplify those, divide them both by 2. That's going to become a 3. So now I have, the 2 is gone, so I have 3 times 10 times 7. So 3 times 10 is 30. 30 times 7 is 210. So the area of that hexagon is 210. So let's do a couple examples. And so here we have another regular polygon. We want to find its area. So we're going to use that same formula. The number of sides times the length of one side times the apothem and divide it by 2. So this shape here, we have 1, 2, 3, 4, 5 sides. It's a pentagon, 5 sides. times the length of one side. Length of one side is 18. Times the apothem, that's 15. And then we're going to divide all of that by 2. Again, I like to work this out by simplifying where I can. So I've got 18, that's an even number. I can divide it by 2, divide the bottom by 2, and that gives me 9. So now I have 5 times 9 times 15. So 5 times 9 is 45 times 15. And I will go ahead and put this into a calculator. Gets me 675. So the area of this pentagon would be 675. So pretty straightforward, just plugging in numbers and working it out. I will do one more example because you'll see some like this. And this is actually, the reason you're going to see this with these radicals relates to something we're going to do next, in the next lesson, which this is kind of leading into. And so you'll learn more about why those come up as often as they do in that lesson. But for this lesson, it looks like it's going to make things more complicated, but it really doesn't. Let's go ahead and set this up. Again, we're trying to find the area of this. It says pentagon. This is a hexagon. So typo there. Sorry about that. So we're trying to find the area of this regular hexagon. And I did say it's a hexagon. It does have 6 sides. 1, 2, 3, 4, 5, 6. So we're going to start with 6. The length of one side is 8. And then the apothem is 4 square root of 3. And then again, we're going to divide that all by 2. And again, I'm going to cancel the 2 out with one of the even numbers. Let's use the 6. So the 6 will become a 3. The 2 cancels out. So now I have 3 times 8 times 4 square root of 3. When I multiply 3 times 8 times 4, 3 times 8 is 24. 24 times 4 is 96. And I still have this square root of 3. And what I'm going to do with that is just leave it like that. I'm not going to do any more than that. And again, once we get into the next lesson, you'll see where this comes from and why it's sometimes best just to leave it as a square root and not work it out any further. But that's all you want to do here is multiply the whole numbers together and then leave the square root as it is kind of tacked on to the end. So the area here would be 96 times the square root of 3. And if you did want to put that in a calculator and estimate that, you could do that as well. And I'll do that really quick. I'll take the square root of 3 and multiply it by 96. And it gives me approximately 166.3. But again, this is the answer I'm really looking for right now, and that's as far as you really need to go with it. So this is finding the area of a regular polygon. Hopefully this will be pretty straightforward. We're almost to the end of the year, don't have much left, but do stay with me for a little bit longer because some of the stuff we are going to be doing I think will be really important, not only in future math classes, but on the ACT when you take that. So, so there you go.